This is the Lab 1 constant velocity analysis. This lab is based on Newton's second law, where Vf equals Vi plus F net over m times delta t, where Vf is final velocity, Vi is initial velocity, F net is the net force on the object, m is the mass of the object, and delta t is the change in time. Since this lab assumes constant velocity, this means that F net equals 0, which negates the second half of the equation and leaves us with Vf equals Vi, or velocity final equals velocity initial. So in order to we made this diagram based off of this video
Go.
that I recorded pushing the volleyball across a table. So from the video, the initial position of the ball is assumed to be 0, 0 on the coordinate plane. The orientation is that the right is positive x and the left is negative x. And the ball is moving in the negative x direction. So this here is the data that was gathered from Tracker and GlowScript. The leftmost column T are the time intervals at which each value was recorded at. The middle column X Tracker was the self-input values from when I hand selected each point on Tracker. The rightmost column X GlowScript are from a code that generated outputs based on an algorithm. This here is a graph of the data points, where blue is Tracker and red is GlowScript. And as you can see, the blue Tracker line is a lot more rocky than the red GlowScript line. And this graph here proves two things: that there is a level of human error involved with self-inputting points, and that there's a difference between observed data and computer-generated data, where observed data is more likely to be realistic, and computer-generated data is more likely to assume ideal conditions in a world where everything is perfect. This is the code that was used to generate the computer-generated output. This is the starter code that was given to us, made with a few minor changes. So ball.m was changed from 0.1 to 0.26, 1 to 0.26. The delta t was changed from 0.01 to 0.167. This change was made so that the GlowScript data would use the same time intervals as the Tracker data. And lastly, ball.vel and ball.pos were changed to use Newton's second law rather than adding an unchanging vector. This is just so that the graphs from GlowScript would be more accurate. Some assumptions that were made during this experiment were that the ball is moving at a constant velocity, the ball is moving in a straight line parallel to the camera, the points input into Tracker are correct, and that the table is perfectly level. Some of the results of this experiment were that the velocity of the ball was determined by its final position obtained from the self-input Tracker data, and that we determined that Newton's second law functions better under ideal conditions rather than real life. So the meaning of this first one is that the final position of the ball was divided by the delta t to obtain a velocity that we just used to determine the midpoints in the data. So what if the orientation of the axes were switched? All of the data points would be positive rather than negative, and just in general, all the signs would be flipped. However, the values of the data points would all remain the same. And what does it mean for the net force on the object to be 0? Well, that would mean that all of the forces would have to cancel out, and in this case, after the initial push, the only forces acting on the ball are force gravity and the normal force of the table to counteract it.